All right, guys, we are on part 2 of our building tables homework. We have our highlighters out, our pencils are ready, and we are ready to use this video to complete the following tables to describe the number of eyes, arms, and legs on an alien from Saturn. Remember that you can pause this video at any time if you can't keep up at the pace I'm going at. Feel free to do so. First, it says, use the variable x to represent the number of aliens. So on all of these tables where we have the variable x, we need to label that number of aliens. Go ahead and do that now. Then it says the variable y represents each trait. Well, the first table says number of eyes. So while x represents the aliens, y represents the number of eyes. The second table says number of arms. So while x represents the number of aliens, this time y represents the number of arms. The third table says number of legs. So, while x represents the number of aliens, y represents the number of legs. This is an alien from Saturn. And we can use this alien to help us fill out these tables. When I look at this alien from Saturn, I see that he has 1, 2, 3 yellow eyes. So I'm going to go ahead and record that one alien has 3 eyes. When I count this alien's arms, I see that there are 1, 2, 3, 4 arms. So I'm going to record that one alien has 4 arms. When I count this alien's legs, I see that there are 1, 2 legs. So I'm going to record that there are 2 legs on this one alien. There is another alien from Saturn. Let's go ahead and record this information in our tables. If we have 2 aliens, we now have 1, 2, 3, 4, 5, 6 total eyes. If there are 2 aliens, we now have 1, 2, 3, 4, 5, 6, 7, 8 greedy, grubby green hands. And when we count 2 aliens' legs, 1, 2, 3, 4. That's 4 legs for 2 aliens. Whoa, here's another alien from Saturn. So now we're going to count the eyes for all 3 aliens. 3, 6, 9. There are 9 eyes on 3 aliens. 4, 8, 12. There are 12 arms on 3 aliens. 2, 4, 6. There are 6 legs on 3 aliens from Saturn. Here's one more alien from Saturn. There are 4 aliens, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 eyes. and I record that in my data. There are 4 aliens, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 arms. And I record that in my table. There are 4 aliens, and I count 1, 2, 3, 4, 5, 6, 7, 8 legs. And I record that in my table. Now it's time to go ahead and go back into our instructions. And it says write a rule for each table. We're going to go ahead and start with the rules for eyes. Every time I added 1 alien, I added 3 eyes. And when I went another alien, it was another 3 eyes. Another alien, that was 3 more eyes. Does that mean my rule is x plus 3 since I'm adding 3 every time? Well, let's look at what x plus 3 looks like. In this table right here, I took my x and I added 3 every single time. And then I got a result. So 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. If the rule was x plus 3 equals y, these 2 tables would match. But as you can see, my y values are not the same, are they? So go ahead. That rule, x plus 3, that's a bunch of hooey. It is not true. We don't want it. They are not the same. They don't match. What does match is when I do times 3. X times 3 is 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. And because it matches every single y value and x value, guess what? My rule is 3 times x equals y. 3x equals y. Whenever we write a number next to a letter, that's multiplication. So 3 next to the letter x is the same as saying 3 times x equals y. Now it's time to do the rule for the arms. I added 1 alien and I added 4 arms. I added another alien. I added 4 more arms. Every single time I added 1 alien, I added 4 more arms. Does that mean my rule is x plus 4 equals y? Well, let's check that out. X plus 4 equals y is the same as adding 4 every single time. 1 plus 4 equals 5. Does that match the 4 I need? No, it doesn't. 2 plus 4 is 6. 3 plus 4 is 7. 4 plus 4 is 8. And when you look, none of my y values match what I'm wanting. So guess what? They don't match. It's no good. And we can just go ahead, get rid of that rule. We don't need it. It doesn't work. What about times 4? 1 times 4 is 4. 2 times 4 is 8. 3 times 4 equals 12. And 4 times 4 equals 16. Now when I compare my y values here, guess what? 1 matches with the 4, 1, 4. 2 aliens have 8 arms. 2 aliens have 8 arms. 3 aliens have 12 arms. 3 aliens have 12 arms. 4 aliens have 16 arms. 4 aliens have 16 arms. This table matches. And this is what happened when we used our rule times 4. times 4 looks like this. 4x equals y, since my variable up there is x. And again, a number next to a letter means to multiply. Great job. Last but not least, we need a rule for these legs. So when I look at my table, I see that when I added one alien, I added 2 legs. One more alien, 2 more legs. Every single time I added an alien, I also added 2 legs. Does that mean my rule is x plus 2 equals y? You should know this by now. No, it doesn't. But we're going to go ahead and we're going to check it because we show our work, we check our work. We don't just guess, we don't just assume. We check. X plus 2 is when you take your x value and add 2 every single time. 1 plus 2 equals 3. 2 plus 2 equals 4. 3 plus 2 equals 5. 4 plus 2 equals 6. So this table, if we did x plus 2, says that one alien has 3 legs. Look at that. Does that alien have 3 legs? No, it only has 2. Do you want to see it walking around on 3 legs? No, that wouldn't, well, it'd be kind of funny. I mean, just to be honest. But the alien doesn't have 3 legs. If somebody walked into your classroom, if your teacher walked into your classroom with 3 legs, that would be a little funky. Well, guess what? This table's a little funky too. 2 alien have 4 legs. Hey, that one matched. Just because a rule works once doesn't mean it's a rule. Rules work every single time. Rules are there because you do it all the time, not just when you want to, not just occasionally. If it's a rule, it's always. 3 plus 2 is 5. Now, if 3 of these aliens, if between these 3 aliens, 1, 2, 3, there were only 5 legs, that would mean that somebody had lost his leg. That's not something that we want for our aliens. We want our aliens to have all of their legs. So guess what? These numbers in our table, they do not match. And because they don't match, guess what? We don't want them. Throw that away. Here, let's put this rule back. This rule, get rid of it. Trash it. Let it go. Let's try multiplying by 2. 1 times 2 equals 2. 2 times 2 equals 4. 3 times 2 equals 6. 4 times 2 equals 8. And if you look up here, 2, 4, 6, 8, 2, 4, 6, 8. 1, 2, 3, 4, 1, 2, 3, 4. They match. Our aliens have the correct amount of legs. Every single one works. It's good. So that means our rule is indeed 2 times x equals y. Again, a number next to a letter means to multiply. Now, you have completed this table, shown all your work, labeled your x and your y's, you created the rules, and now it's your turn. You need to go on to part 2. You need to use this picture of an alien from Jupiter to complete these tables about the number of eyes and the tentacles for an alien from Jupiter. Make sure that you write a rule for each of these tables.